Imagine the storage vault of a major museum. A camera slowly glides along endless shelves filled with pottery shards and fragments of statues, the familiar witnesses of bygone eras. Suddenly, it stops on an object that looks completely out of place, a complex mechanism with dozens of bronze gears recovered from the seabed, or perhaps an ancient clay jar with strange electrical internals. History, as we know it, is a linear path from the simple to the complex. But what if, among its records, there are items that disrupt this order? Objects that simply shouldn't have existed in their time. There is a special term for such finds, OOP art, or an out-of-place artifact. Popularized in the 1960s by naturalist Ivan T. Sanderson, an OOP art is more than just an old object. It is an item whose technological or informational characteristics dramatically outpace the presumed level of development of the civilization that created it. It's like finding a modern smartphone in an untouched pharaoh's tomb, a chronological paradox that calls into question either the dating of the artifact itself or our entire understanding of that era. So what are these discoveries? Are they mere curiosities, dating errors, and elaborate hoaxes that science rightly ignores? Or are they genuine fragments of a completely different, forgotten chapter in human history, a key to understanding lost knowledge? Our investigation is a kind of trial for history itself. On one side of the scale is the established scientific worldview. On the other, the silent testimony of these artifacts. At stake is our entire accepted picture of the past. Our journey begins in the year 1900. Off the coast of the Greek island of Antikythera, a team of sponge divers led by Captain Dimitrios Kontos was forced to take shelter from a storm. When the sea calmed, they decided to explore the seabed. The first diver to surface was horrified, describing a field of rotting corpses and horses. These were not bodies, but ancient bronze and marble statues, the remains of a Roman shipwreck that had sunk 2,000 years ago. From a depth of 45 meters, about 150 feet, they recovered numerous treasures, amphorae, jewelry, and works of art. And among them was a shapeless, salt-encrusted lump of bronze fused with rock. No one could have imagined that this unremarkable fragment would prove to be a far more significant find than all the statues combined. For decades, this artifact lay in the National Archaeological Museum of Athens. It was considered nothing more than a fragment of a broken statue, or part of some simple navigational instrument. Its true nature was securely hidden beneath a thick layer of marine deposits. It was not until 1902 that archaeologist Valerios Stais, while cleaning the find, noticed something incredible inside, a gear wheel. His suggestion of a complex mechanism was met with ridicule. The academic community simply could not accept the existence of such technology in antiquity. It contradicted every textbook. The artifact was shelved again for nearly half a century. The turning point came in the mid-20th century with the advent of new research methods. First X-rays, and then powerful computer tomography in the early 21st century allowed scientists to look inside without destroying the fragile object. Layer by layer, technology revealed a breathtaking picture, a highly complex system of at least 30 bronze gears, some the size of a coin, with perfectly calibrated triangular teeth. Researchers from the Antikythera Mechanism Research Project used an 8-ton CT scanner to virtually disassemble it. The process was akin to dissecting a Swiss watch created 1,500 years before the invention of clockwork itself. Its purpose also became clear. This was not just an astronomical device, but the world's first analog computer. It modeled the movement of the sun and moon through the zodiac, predicted solar and lunar eclipses with astonishing accuracy, tracked lunar phases, and even indicated the dates of the Olympic Games. The mechanism accounted for highly complex astronomical cycles, such as the 223-month Saros cycle for predicting eclipses. All of this was operated by a differential gear system, a technology that humanity was thought to have rediscovered only in the 16th century. Herein lies the main paradox. The level of miniaturization and engineering ingenuity in the Antikythera mechanism has no parallel in the ancient world. After its creation, history experienced a technological gap of nearly 1,500 years. It was only in the late Middle Ages that the first, far more primitive astronomical clocks appeared in European cathedrals. It's as if humanity had invented the microprocessor, only to completely forget the technology and spend the next 15 centuries relearning how to use a simple abacus. This is not just an artifact ahead of its time. It is a technological peak, followed by an inexplicable, profound regression. The Antikythera mechanism is an undeniable fact. It proves that a tradition of precision mechanics existed in antiquity, about which we know almost nothing. Who were these geniuses? Was this a singular stroke of genius, or the legacy of an entire school of engineering? As far back as the 1st century BC, Cicero mentioned two similar devices created by Archimedes. Perhaps the Antikythera mechanism is not a lone miracle, but the last surviving example of a lost technological tradition. And the main question remains, why was this knowledge completely lost, leaving almost no trace behind? If the Antikythera mechanism challenges our understanding of ancient mechanics, other finds question our knowledge of the era's chemistry and physics. In 1936, during excavations near Baghdad, archaeologists discovered a small clay jar about 2,000 years old. Inside was a copper cylinder, and within that, an iron rod. Experiments showed that if an acidic solution, such as grape juice, was poured into the jar, it would generate an electrical voltage of about 1 volt. This became known as the Baghdad battery. The most popular hypothesis for its purpose is electroplating, coating one metal with a thin layer of another, for instance, to create inexpensive gold-plated jewelry. However, most historians are skeptical. They believe it was simply a vessel for storing sacred scrolls. The main argument against the battery theory is practical. No wires or electricity-consuming devices were found nearby. Furthermore, the jar's neck was hermetically sealed with a bitumen plug, making it impossible to regularly add electrolyte. It is a perfect example of an artifact whose interpretation depends entirely on the researcher's perspective. From chemistry, let's move to cartography. The map of Turkish Admiral Piri Reis, dated 1513, depicts the coasts of South America and Africa with surprising accuracy. But the most astonishing feature is in its lower section, which shows a landmass whose outlines are eerily similar to the coast of Antarctica, but free of ice. The problem is that Antarctica was not officially discovered until 1820. Piri Reis himself noted in the margins that he compiled his map from over 20 ancient sources, some possibly from the Library of Alexandria. This has led to the theory that he had access to maps from an ancient maritime civilization capable of global voyages thousands of years ago. The scientific explanation, however, is far more mundane. It is likely a distorted depiction of the Patagonian coast, which the cartographer, following the ancient idea of a symmetrical southern continent, simply bent eastward. The list goes on. The relief in the Temple of Hathor at Dendera, which bears a strange resemblance to a vacuum tube with a filament, the gold figurines of the pre-Columbian Quimbaya culture, which modern engineers have recognized as aerodynamically sound models of aircraft, the perfectly round granite spheres of Costa Rica, weighing up to 16 tons, whose origin and purpose remain a complete mystery. This kaleidoscope of finds from different eras and cultures raises a common question. How should science respond to so many facts that do not fit into the accepted picture of the past? Science responds to this challenge with a caution born of centuries of experience. For a historian or archaeologist, an artifact in isolation means very little. What is crucial is its context, the place where it was found, the layer of earth it was buried in, and the objects that surrounded it. This is called stratigraphy. An artifact torn from its cultural layer is like a word taken out of a sentence. It can be interpreted in any way. A sad example is Heinrich Schliemann's excavation of Troy. In his quest for Priam's gold, he dug straight through the layers, forever destroying invaluable information about the city's life. Therefore, the scientific community has developed several standard explanations for out-of-place artifacts. The first is misinterpretation. The Dendera relief is not a lamp, but a mythological depiction of a god being born from a lotus flower. The Baghdad battery was most likely a vessel for storing scrolls. The second, and most common explanation, is clever forgery. The famous Ica stones, engraved with images of humans alongside dinosaurs, were revealed to be the work of a Peruvian farmer, Basilio Uschuya, who confessed to making them. And third, we simply underestimate the ancients. The Antikythera mechanism is not a gift from aliens, but a testament to the genius of Greek engineers, whose capabilities were far greater than we thought. Here, science applies the principle known as Occam's razor. The simplest explanation is most often the correct one. However, critics argue that this position sometimes turns into dogmatism. A commitment to the established worldview can prevent an objective look at anomalous data. Any paradigm-shifting idea, like Copernicus's heliocentric system, has always met with resistance. That said, history also offers counterexamples. The discovery of Göbekli Tepe in Turkey, a temple complex built by hunter-gatherers 12,000 years ago, completely overturned the theory that monumental architecture only appeared after the advent of agriculture. This proves that science is capable of what the philosopher Thomas Kuhn called a paradigm shift. But for that to happen, irrefutable, systematic evidence is required. This brings us to the central conflict. As the astronomer Carl Sagan said, extraordinary claims require extraordinary evidence. The burden of proof lies with those who challenge the accepted chronology. Until an entire workshop for producing Antikythera mechanisms, or an ancient power plant, is found, most such discoveries will remain on the fringes of the scientific world. This fosters a kind of shadow science, where even respected researchers study anomalies, but hesitate to publish their findings for fear of damaging their academic reputations. But where academic science stops, the territory of the boldest hypotheses begins. The most famous of these is the paleocontact theory. Its proponents believe that in the distant past, Earth was visited by extraterrestrial civilizations that shared some of their knowledge with humanity. This idea was made world famous by Erich von Däniken in his 1968 book, Chariots of the Gods. In this view, out-of-place artifacts are either tools left behind by the ancient astronauts themselves or clumsy copies made by humans. Much like the cargo cults of Melanesia, where islanders built straw airplanes hoping to bring back real ones, ancient people may have tried to replicate divine devices without understanding their principles. There is another, more terrestrial, but no less revolutionary version. What if, long before Egypt and Sumer, a global, highly advanced human civilization existed on Earth? A hypothetical Atlantis, destroyed in a global cataclysm. This idea dates back to Plato's dialogues, Timaeus and Critias. In that case, out-of-place artifacts are simply the miraculously preserved fragments of its former glory. Interestingly, this hypothesis has found unexpected support from geology. The theory of a comet impact at the end of the last ice age could explain both the mass extinction of megafauna and the demise of such a civilization. This leads to the idea that history may not be a linear ascent from savagery to progress, but a cyclical process. Civilizations are born, reach their peak, and then collapse, only for the cycle to begin anew. This concept is present in many ancient cultures, from the Hindu doctrine of the yugas, or world ages, to the Greek Stoics. In this view, history is not a ladder we steadily climb, but a giant Ferris wheel with cycles of rise and fall. In such a model, the Antikythera mechanism is not an anomaly, but a perfectly normal product of a previous peak in technological development. Finally, there is a philosophical alternative. Perhaps we are looking in the wrong place. The ancients may not have possessed high technology in our sense, but rather a different, more profound knowledge of the laws of nature, geometry, acoustics, and astronomy. The science of archaeoacoustics, for example, studies how megalithic structures like Newgrange in Ireland were designed as resonators to affect human consciousness. Mathematicians still debate whether the astonishing precision with which the numbers pi and phi are embedded in the geometry of the Great Pyramid is mere coincidence. These are products not of machines and electricity, but of a lost knowledge, with a capital K. So what have we concluded from our journey? The world of out-of-place artifacts is extremely diverse. It is a field where genuine technological diamonds, like the Antikythera mechanism, lie alongside obvious forgeries like the Ica stones, and controversial finds whose purpose remains a matter of debate. They cannot all be measured with the same yardstick. Science successfully explains the origin of many of them, but some, the most significant ones, remain a true challenge to history. But one undeniable conclusion can be drawn. Our ancestors were far more inventive than popular culture often portrays. We suffer from a kind of chronological snobbery, the conviction that we are the pinnacle of development. However, the mere existence of the Antikythera mechanism forces us to reconsider the entire technological potential of the ancient world. History is not a straight line of ascent. It is a complex path with peaks, valleys, and long-lost trails. And therein lies the true value of these finds. Their primary role is to be an intellectual provocation. They force us to doubt, to ask uncomfortable questions, and to challenge established views. They play the same role for history that scientific anomalies play for science. The strange orbit of Mercury did not fit Newton's laws, and it was the attempt to explain this anomaly that led Einstein to the general theory of relativity. These artifacts protect history from becoming a frozen dogma, reminding us that our past is still full of blank spots. Perhaps the most difficult question is not how the ancients could have created these things, but how the knowledge of them could have been completely lost. It is a powerful reminder of the fragility of civilization, Imagine a future archaeologist finding one of our smartphones. Without electricity, servers, or satellites, it would be just a useless black rectangle, a perfect out-of-place artifact. These objects silently ask us, which of our present-day achievements will survive for millennia, and which will become inexplicable curiosities for the historians of the distant future?